Awesome. All right. So thank you everyone for being here. And I know it's the last session. You had a lot of amazing sessions until this point, and I hope you still have some energy because we're going to learn a lot in here. I really want to address that this presentation and the code was like 99.9% built by Samuel Hinton. He just had a throat surgery, so he cannot speak. But he's there in the chat, you know. So if you have any questions for him, or in the process, he will also be able to answer while I'm talking. So if you have any questions in the process of the workshop, make sure to say anything in the chat, and we will have a session in the middle of the workshop for just some Q&A and some refresh, and then we will continue. But you can ask questions at any time. All right, cool. So let's get started with this. Let me share my screen. I'm gonna share my screen now. Let me know when you can see it, please. Awesome. All right. So hopefully you're seeing the slides now. Let me tell you right now that if you want to access all of this, there's a link. I'm gonna put it in like big here so you can all see it. If you go to this, let me put it just big in here. So hopefully you're all seeing my screen now, and you can see this link to GitHub. In this GitHub link, you will have access to everything in this workshop: the code, the presentation, the data, everything. So make sure to clone this repo that is in Sam's GitHub. All right, and if you want, please give us a star. All right. So in that link you have in there, we'll have the presentation, and the presentation I'm gonna give it so you have an idea of what we're gonna be building in this workshop. Again, this is being presented by me, but all of the code and the investigation was done by Samuel Hinton. Again, he's recovering from a throat surgery, so he cannot be speaking, but he's there. He's just right there in the chat for everyone to if you want to ask him any question, he's just right there. All right. So the first thing we have to understand is that to create data science products is not easy. There's a lot of things going on, and let's say you have some raw data files. To be able to create a model, if you have a big company, it's normal that there will be several groups working with that data, and all of them will be making models. Some of them will be making reports. Some of them will be making dashboards, and sometimes those dashboards depend on the models for one group. Sometimes the report depend on the models of a different group. Sometimes the reports are also providing information to the dashboard. So it's not easy to track all of this happening at the same time. And if you remember, this was not something super strange in computing back in the day. If you remember or have an idea of the history of all of this, when the person who created Linus Torvaldi, he was trying to collaborate with more people. He realized how hard it was to share code, to manage the versioning of the code. So he created Git. So now we're all used to using Git, but that's only for the code. But machine learning is not only code. You have models, you have objects that needs to be replicated, that needs to be downloaded and used for different people. Sometimes you need to read some data or to read a model for something else. And so it's not easy to track all of that. So let me paint you another picture right now. So I told you that the normal case is you have something like this, all right? So you have some raw data in your computer, and you can that can be also on the cloud. can be in databases that are can be complicated or very simple, and most likely you have a combination of all of that. You have a combination of Excel files, CSV files. You have something that can be in the cloud, some local CSV files you have around. And with all of that mess, we managed to create data products. And these data products normally are like reports and dashboards. Um, Normally, what a company will want to do with all of that data is to train a model. So when you train a model, what the basic idea of training a model is to deploy that model. And that deployment can be like an API, it can be a REST API, it can be a report, it can be a dashboard, or it can be, the result of a model can also be a CSV file. So if you have done this in the past, you know how hard it is because there's a lot of things to take care. You have to take care of the data. That data can be streaming. That can be, as I said in the beginning, in the cloud. You can have databases that are relational databases. You can have NoSQL databases. You, you can have distributed file system like HDFS from Hadoop. And normally, again, it's a combination of all of this, right? It's a combination of all of these things in here. So when we go to the process of training the data, of course, there are some missing steps here where you are understanding the data and you are preparing the data, all of that, that is included in the training. So you normally use for that Spark or Pandas or more fancy stuff like Dask or Rapids or stuff like that. And then you're building models where PyTorch or TensorFlow or XGBoost, scikit-learn. And then the deployment can also be complicated. You have a lot of things to think about there. If you want to do it in a containerized way with Docker or with Kubeflow and Kubernetes or something like SageMaker, you can even have some Spark models there. And again, most likely you have a combination of all of this. And also you need to add that versioning, the metrics, and tracking. So it's not an easy process. It's not an easy process, and if you've been doing data science in the past years, you know how hard this can get. So what we're going to show you in this workshop is how to use basically a library or a framework created by the great people at Databricks that is called MLflow. And MLflow has different applications and different APIs. We're going to be talking about here four. The MLflow tracking that is used to track, log, and query models, metrics, parameters, and code versions. You also have MLflow projects where you package the data and the code in a format that you can reproduce it anywhere. You also have MLflow models that can be deployed, and you can deploy in diverse location, and also you can deploy different types of ML models with different libraries. And finally, we're going to talk about something called MLflow Model Registry. We're going to be storing, annotating, and managing model staging and versioning in a central repo. So this the idea of all of this is to as a response of as the complicated stuff happening when you're actually building the model. I mean, I think we can talk about how really hard is to build a model right now. It's not that hard. I mean, if you have the right tools and the right data, being able to do cross validation and model selection, I mean, that's interesting. It's not the hardest part. The hardest part is actually taking care of everything happening when you're trying to deploy a model or have a version of the model or being able to actually use it in production. So again, the first part is MLflow tracking, where you can track different metrics and models and more stuff that can be stored in notebooks, in local application, cloud jobs, and then you can be able to show that tracking in your API in a command line based way, or also in the UI that we're going to see later. The MLflow project is something very interesting because one of the most important pieces that we're trying to do in data science is to make it something that you can reproduce. Science has to be reproducible. You need to have a way to replicate what others are doing. So one of the ways where we're working here and what we're going to do. So I'm going to show you here how you can put all of your dependencies, configuration, your code, and your data into a place that you can remotely execute that or locally execute that. Um, Something was missing there. Okay, and the MLflow model is something huge because so in most cases, data scientists are free to use whatever they want in a library. Some companies may have some restrictive ways of working in data science, but it's like in most cases, it's a combination of Python, R, Spark, XGBoost, PyTorch, and TensorFlow, and Keras. So being able to productionize those models, if you are doing it one by one, that's just very hard to do. And the great thing about MLflow is that it's is model agnostic. The way where that you can deploy your models allows you to use a lot of different libraries. Not everyone, not each one of them, but there are a lot of different libraries that can be used with MLflow, where you can be deploying that, and not only that, because you're going to be having also the data and all the steps working there, and you can use that for serving tools. You can do that for batch and stream scoring, and also to inference code. Um, okay, so the tracking server is something that is kind of new in MLflow. Sorry, the model registry is something that is kind of new in MLflow, and it's something that is very important because sometimes when you're working in data science, you need to have like a development area, a staging area, or something that we also call experimental, staging, and production. What if you are creating a model and someone else just built something that can be better for what you did, and you want to deploy that model without killing everything that is happening right now or is in production? So with MLflow, you have ways of staging models, testing new models, and productionize new models without breaking anything. So this is bringing a lot of this stuff from software engineering that was missing in data science. And there are more things that can be used together with MLflow. We're not going to have the time to talk about all of them, but one of them that is actually very useful is called Airflow. And in Airflow, it's something that we will be using to transform our ML pipelines into something called a DAG. A DAG is an acronym for Directive Acyclic Graph, right? And it's just this what you're seeing in there. Okay, this thing you're seeing below there, like you process the data, you create your models, and you get the best model, and you register something. That in there, that's a DAG. Okay, and we're gonna be trying to express all of we're doing in this DAG type. So Airflow can run that. Let's say every single day at 6 a.m. So this is interesting because you don't want to. I mean, even though MLflow has all of these great advantages, it needs you to code and run it. But what if you want to report every day at 6 a.m. at your boss desk? So if you don't want to wake up at 5:30 and just click run, this is a great way of doing that. With Airflow, we're going to be running all of the MLflow tasks in a DAG format, so everything can run smoothly and perfectly without you being like intervene in every single step. You just have to schedule it, and that will work for itself. All right. So hopefully you have an idea of what we're going to build in this workshop. Again, if you have any comments or questions, make sure to put them in the chat. Sam is there. I see him answering people. So thank you, Sam, for being here. So if you have any questions, he should be able to answer you perfectly. And again, we're going to have mid Q&A in like 43, 45 minutes, and then we will continue. Okay, so let me remind you again. This link is posted in the chat. All right, so if you're in the chat, you can see this. And this is the GitHub repo for Sam from Sam. Well, you have everything in the code. So let me go to this repo again here. Nope. Okay, here it is. So what do we have in here? We have in here every single instruction. Again, you're gonna need to run. If you want to run this with me side by side, you can do it, okay? If you don't want to do that, you can just check the code, like check the notebooks and stuff like that. But it's better if you run along with side with me. Okay? If you have the chance, please just clone the repo and be here with me running everything, because I think that will be easier, and also you can get the actual experience of doing all of this. All right. Um, so the first thing we see here is that we have some structures. Okay, we have something called 1, 2, 3, 4, and 5. You have the presentation is right in here as a PDF if you want to download that for later. If you want to use that, you have the requirements and more stuff. So what's the first thing you have to do? We're going to be using something called SQLite to store some of the information uh, from um, from from MLflow. So you will need to install SQL Alchemy. That's also important for Windows user. Okay, sometimes if you're on Linux or if you are on Mac, this could be installed for you, or maybe you installed it before. But if not, just run this conda install SQL Alchemy, and we're gonna be using this version in particular, 1.3.13. Okay, so what's the process in here? When you um, when you clone the code, if you don't know how to clone it, it's just git clone a space, and you put in here clone, and you click here this little pad. So you click in there, and you have here the information, and you hit enter. Then you have everything. Okay, you will have all the data, all the code, presentation, anything you want. As Okay, so hopefully, I'm gonna give you just like 2 minutes. So because I don't want you to like fall back in here. So I'm gonna give you 2 minutes to download the code. And after that, I'm gonna be starting. All right. So uh, make sure to go to this web page. Again, I'm gonna put it in here so you can all see it. It's github.com/sam reay/DSGO pipeline. All right, so go to this web page. You will have this. Let me just don't close that. You have here this README, and this README is where we're gonna be expending the most time, understanding what's happening here. Okay, so the first thing again, I told you to install SQL Alchemy with conda install SQL Alchemy, and when that's done, you have to do pip install -r requirements. Okay, and what are our requirements for this presentation? Let me tell you here that we have NumPy, Pandas, Plotly, SciPy, Dash, Scikit-learn, TensorFlow, MLflow, Matplotlib, and so on and so forth. So when you do this pip install -r requirements .txt, you're going to be installing everything you need to run this code. Okay, so as I mentioned in the beginning, we have some directories. And the first one, what Sam did was try to simulate a somewhat chaotic and unstructured way that some data science project begins. And this is not entirely crazy. When we go to there, we're gonna be seeing 3 notebooks. Okay, sorry. Yeah, it's gonna be 4 notebooks, by the way. One is gonna be with the processing of the data, where we're gonna be downloading the data and understanding a little bit about it. Then we're gonna be build 3 models. We're gonna build a linear regression, random forest, and then we're gonna build a keras model. And you also have a directory for a report that is containing a weekly report that should go to some clients maybe. And finally, to the directory containing the dashboard. And we're gonna have this dashboard to be very simple, okay? And this is not this is not a presentation about Dash. I'm just gonna use it to show you an idea on how this could look like when you don't have a structure in the beginning, and then when we have the models track and all of that, we're gonna see a different version of that dashboard. using all of the principles I've been talking about um, up to that point in the presentation. So the first goal will be just to understand the process that the people are trying to build, like what's the business problem they have in their minds, and then they created some notebooks and some inspiration and some stuff, and then we're gonna be tracking those information. We're gonna be recording the hyperparameters and logging their metrics and artifacts. Uh, After that, we're gonna be choosing one of these models to production, and we'll be covering how to stage model and how to deploy models again. And finally, we're going to be covering the process of transforming all of this into a multi-stage workflow and hook that, as I mentioned in the beginning, to the dashboard in the end. So I'm not going to go here yet. All right, there are some things you have to do. And keep in mind that if you're running this side by side with me, you're going to need to have open several terminals. All right? Not only one terminal, but you need several terminals open. Okay? I'm gonna be making sure that you understand when to open one and when to close another one or something like that. But you need to have several. I have six here open. You're not gonna use six. It's probably be like three or four. I know it's a lot, but it's needed for running all of this. So what's the first step? What's the first step? Again, I'm not going yet to understanding the data and all of that. I just want you to understand how to do all of these things that we're gonna do later. So the thing is, we need a tracking server, okay? And we need something that can work like Azure or Amazon, but to make it easier for this workshop, Sam created a SQL-lite database that is going to store all of the information coming from MLflow. So if you have installed the SQL Alchemy to this point, and you also ran the pip install -r requirements.txt without any error, you should be able to run what I'm going to run right now. Okay, so what I'm running right now, it's something, let me give me a second. So what I'm creating right now is that I am creating a basic SQLite database that is going to be storing all of the things that are going to be an output for MLflow. To do that, before again, this is before working with MLflow. Okay, this is just to set up everything. I'm going to do MLflow server minus backend minus store minus URI, and it's gonna be SQLite or SQLite ITE dot slash. Notice there are three slashes in there, right? And I'm gonna write mlruns dot db. Okay. Now I'm gonna be saying where's gonna be uh, my default artifact root. I'm gonna be putting that. So this is something tricky, right? And this can be one of the sources of error in the process of this thing we're gonna be building. So if you receive some of the errors that may happen to me as well, I'm gonna be telling you how to fix them, okay? And sometimes it's because you need to have a way of going to the right folder for the ML runs. If you are not going to the right folder in the ML runs, you may have an error. So I'm gonna say here now default artifact. Something weird happening. All right, this is just out of control. Okay, here it is. Okay, its server is minus backend or URI and SQLite is ml runs.db minus default artifact. See that this is weird? Okay, something's happening to my. Maybe it's because of this. So let me. Sorry for that. So it's artifact in here. root. And I'm going to be putting here home, okay? So to do that, you need to put here the your a file. It's going to be a file, and you're going to say here that something is happening to my terminal. Okay, it's file. Okay, and it's going to be home, Fabio. The home, Fabio. Let me just maybe this would be like this. That. It's going to be like this. Home, Fabio, run. So what this is doing is creating the folder. Okay, so it's something. Okay, one. I'm missing one flash here. Okay, so now it worked. All right. So if I go to my home folder, okay, from home in here, let me go here, in my home folder, I still have something called ML runs. Okay, and here it is, ML runs. Right, so you have everything in here. So again, we will be, I mean, one of the things that worked for me when working with this structure in Mac in particular was to replicate this in some of the steps, and I'm gonna tell you why soon. Okay, but I just wanted to you to run that, and again, I'm just creating the SQLite database where we're storing everything that is going to be the output of MLflow. So what's happening now? What we do now is that, so let me just put this down for a second. So the idea now is that we will start by going into the first folder, okay? And we're gonna be checking some stuff there, okay? We're gonna be checking some stuff there with that are just the beginning of any data project, all right? So let me pull this again. And the idea here is for you to check like how are things done in a company. And this is normal for a lot of people, okay? So if you go to the first folder, you have several files in there. Mm, when you are in here, um, maybe better when you are in here in the root directory, just open Jupyter in there. Okay, so Jupyter notebook. I'm gonna be using the notebook, not the Jupyter Lab, because sometimes some of the things I'm gonna be doing are with Plotly, and they, Jupyter Lab and Plotly are not perfectly enabled at this point. You have some ways of installing some widgets so it can work, but it's easier to do it in the notebook. All right. So let me go here and go to the starting point, and this is what you have. Okay, you should be seeing something very similar to this. And we will go to the first thing called make process data. Right? So I'm going to close this terminal for now because we're going to go here. So what we're going to do in here, and as said here in the README, is that we're going to actually see the process of you building a model in machine learning. And this is what we normally do, okay? What I'm gonna show you now is like our normal workflow. And then when we see the problems with that way of working, I'm gonna be transforming all of this into something with MLflow. So you see how it works. All right, so let me go here and go to understanding the data. So the first thing we have to do is to import pandas, seaborn, and just remove the warnings in here. And the data we're going to be using through all these experiment and workflow is a data from the Open Power System data. Okay, so if you open this link in here, you have the information for the data in particular that you're seeing in here. That's the time series data. What you have in there are different types of time series relevant for power system modeling. like electricity consumption and stuff like that for 37 European countries, as well as wind and solar power generation in prices and capacities for a growing subset of countries. Cool. So this is one of the pieces we're going to be using this data here. Again, I'm replicating here the process after business understanding, and this is very important to talk. Data science is not downloading data out of nowhere and just building machine learning models. You need to have a good idea of the problem you have in mind. You need to have an idea of what's the business objective with this project, and then you can get started to gather the data to solve it. Right? So the first thing we have to take care here is to download this data set that is a time series. And I just put here in the read CSV the link directly to there. Okay, so you need internet to run this. If you don't have internet, you will not be able to run this piece of code in here. So this code will be reading the data file. Okay, and the latest version is for the last year. Okay, so that's the one we're going to be using in there. And I'm going to name that df power all as a data frame in pandas. By the way, I'm assuming I will assume in all of this um, workshop that you understand Python, of course, that you understand pandas, NumPy, scikit-learn, and a little piece of Keras. I'm not gonna be taking the time to explain in detail each one of the models because that's not the key point of the workshop. It's better how to understand, how to track, and everything like that. But if you have any questions or something like that, I can point you to locations where you can learn more about how to build machine learning models in Python. Great. So we have in here our model, sorry, or data, and with a head we can see it. So as you can see, the index is a timestamp. And apparently we have data from 2004. We are not entirely sure. We may check that. And you have also here some data for some countries. The two letters in cap you have before each one of these columns is a country. So if you want to know which country is this, you have to check like what is the acronym for UA, and you'll see the country by itself. Okay, so we have some data here for our purposes. We're only going to be choosing the actual solar generation and the actual wind generation of power by Germany. Okay, so that is DE from Deutschland. So if you want to go and search for the data for Germany, that has the DE in there. Okay, so I'm just gonna pick the data from Germany in here, and actually I'm just gonna pick the solar data and the wind data. To have an idea of what's happening in here, I'm gonna plot it. And I don't know if you knew this, but there's an easy way right now to create plots with Python and Plotly and just with pandas. And the way I built this Plotly plot was only by the same way you will do it with Matplotlib. What you have to change is this code here. pd.options.plotting.backend equals to Plotly. All right. So that is the place where you change the backend for pandas plotting. And so this is awesome because you have here your Plotly plot without caring about anything about Plotly, because this is the same exact piece of code that you will be having if you're using Matplotlib or anything like that. So that's kind of cool. Okay, so in here I'm plotting for each one of the data points the solar generation and the wind generation for Denmark since 2006 apparently. Because there's a lot of missing data in here from 2006 until something like 2013. We're gonna be only interested because, as you can see here, we have data for wind, but not for solar since 2013, something like that. So I'm only gonna pick here. So I'm gonna be creating like a filter to only select data from 2013 and forward. So in here, that's the actual code to do that. I'm just creating a basic filter to select the data only for 2013 moving forward. And the other change I'm gonna be doing is that I'm gonna be changing the name of the columns because it's kind of annoying to write DE solar wind generation actual. So I'm just gonna put in here solar MW and wind MW, and that stands for megawatts. Okay, so I'm gonna do that, and also I'm gonna be plotting this. Okay, so if for some reason the plot doesn't show, let me test this again in here. You run it again. So if for some reason the plot doesn't show, you need to save this into a fig, and then you have to put fig.show. So sometimes that's one of the problems of using Plotly. It's not perfectly enabled with pandas. So if you want to have this plot, I mean, in this case for me, it asked me to do this. Okay, so if you're running this without Plotly, it's okay. You won't have any issue. But if you have Plotly as a backend, sometimes, not every time, and this is the weird part, you will need to save your plot into a figure and then to show it. Okay, so this is the same plot as above, but now we have everything smooth, and because we have data since 2013, so we have data for both the solar and the wind megawatts. This is only for Germany, by the way. I'm gonna be creating a different plot in here. So this plot is being created in here for every year. With this role in here, I'm creating a window function to just have the year 2015 and to work month by month. Okay, so this is the data of 2015, and we can see here how's been the generation of power for solar and for wind in Germany in this year in particular. So the blue one is the solar and the red one is the wind. Okay, so we're seeing here, this is just a basic plot again, but this is a more restrictive plot. This is only working with the this in here with Plotly, but we're you can do this with whatever you want. Okay, I'm just using Plotly as a backend, but you can choose whatever you want. Right. So now we have the data we want in there. We want the solar and the wind for Germany, and the other piece of data we want to have is the weather data. And this weather data, I'm gonna be opening this again in here, is hourly geographically aggregated weather data for Europe. And this package contains weather data relevant for power system modeling at hourly resolution for Europe aggregated by renewables. Okay, so this is what we have. And the data we're using for this project is also it's going to be coming from this weather data. There's something tricky in here, and the tricky part is that this is stored in the Open Power System data as a zip folder. So you will need to download the zip folder, extract that, and only get the CSV. So we took care of that for you. So what you only have to do is to run this request zip file and IO import and then run this code. By the way, this can work for everything you want. Okay, so if you have, I think this is the case for pandas right now. Okay, so let me tell you this: if you have a zip folder with only a CSV file inside of that, you can use read CSV directly. You don't need to use a zip file or anything like that. But because in this zip folder you have more than just the CSV, I needed to create this zip file thing. Okay, so I'm gonna be extracting all of that, and I'm just gonna selecting the weather data. So let me run this right now, and after that's run, we're gonna be working with the weather data. So this could take a moment because this is using my internet to download the data. Wait for a second in there. It ran. So now we're only gonna read the weather data, and I'm just gonna show it to you with dot head. And wait for a second in here. So here we go. Again, in here we have data for all Europe. Again, each one of these two letters is a country. I think this is Bulgaria. All right. So you can just you have data for every country that is in this project. You have it in here. Okay. So because we're only interested in data starting from 2013 and from Germany, we're only going to be selecting some information. So we're going to be selecting the wind speed, the temperature, the radiation direct, and the radiation diffuse since 2013 for Germany only. So this is going to give us only the weather data for Germany. You can also plot this so you have an idea what you have. This is going to be a weird plot because uh, you may not understand this perfectly, but it's not that entirely weird because if you see here, this is the temperature, okay? And as you can see here, it goes down in December and January because that's winter, and it goes up at July because that's summer. So again, this is some data that's easy to understand. The temperature is easy to understand. So in here you have all of this for 2013 until 2017 for Germany. We can also plot something else. We can also plot like a scatter matrix, and this is something like a per plot with pandas to show the dependency and the way one variable can depend on the other one. Okay, so in here we're seeing the histogram for each one of these variables and also a scatter plot of let's say temperature and wind speed or temperature and direct horizontal radiation. So here you have some information on how they're correlated. For the end part, we're going to be combining the data, all right? So the combination of the data is going to be a combination between the weather data and the power data. We have something awesome in our case that the index is the same for both data sets. So it's not going to be because we're using this timestamp and because they were collected by the same people, they have the same index. But if you don't have that, you can use something like merge ASOF that is something like a coarse scale aggregation of the data. But luckily for us, we can have an easy join of the data. So I'm just combining in here the data from the weather and the data for the power consumption. Okay. So after I do that, I have this beautiful set of data that is by each timestamp. You have the solar megawatts, wind megawatts, and the wind speed, temperature, radiation, and all of that. You can have here your info, so you can have a basic understanding on some idea. As you can see here, we have the data type is float 64. By the way, if you're using pandas 1, this can so I'm using pandas 1.0.5, so they have changed a little bit the outputs of some of their function. This was not like this before pandas 1. This is interesting. So in here we have for each column how many non-null variables sorry, observations we have, and we have the type, so they're all floats. For simplicity, and again, I'm not trying to replicate the whole data science project in here. Again, you're going to need more business understanding. You're going to need to see from the people in the project if you can drop the the missing values, or if you need to augment it or imputate them. So this depends on the project. For our case, where I'm just going to be dropping all of the missing values. And also because as you can see here, we have this big scale for solar and wind. I'm gonna be multiplying that by 0.001. So we actually have the megawatts in there. This is the transformation to megawatts. The final step in here. Okay, thank you. The final step in here is to rename the columns, so it's easier for us to read them and talk about them. Okay, cool. So I just renamed all of our columns. I just save everything. So this is my step for processing the data. All right. So this is all I did to download the data and prepare it for what we're gonna do. Uh, Before ending in here, I'm gonna be doing a per plot. Uh, this is from Seaborn, by the way, and this is something like the scary matrix plot from before. This is just gonna give us the histograms for our actual data, as you can see here, and finally it's gonna give us the scatter plot for each one of the variables. Okay, so how one variable changed with the other one, and you can see here more about correlations. Final step to create the data set called Germany. You already have Germany in there, okay? So if you're not running alongside with me, you have the output of this notebook that is just Germany. So you have all of that in there. All right, so let me close this. Let me just save it. Second, we don't have any issue later. Okay. And I'm gonna be now shutting down this notebook. The next one is we're gonna be building a linear regression. Okay, so this linear regression is something that you're normally doing all the time. And by the way, let me tell you what's the problem in here. We are working here with solar and wind data, and we want to predict exactly that. So the idea here is that we're going to be predicting the solar and the wind the wind and the solar consumption from wind speed, temperature, radiation, horizontal and diffuse. So as you can see here, these are our Y's for our model. So let me go step by step. Let me just start by running and importing our libraries in here. I'm gonna be defining our evaluation metrics. We're gonna be using the root mean square, the mean absolute error, and also the R square or the R2 score. So that's what we're gonna be using to test our model. Now let me read this data in here, and we're gonna be reading this gigawatts. By the way, I think I said something that's not correct. In the end part, we were changing that from megawatts to gigawatts. Okay, with that multiplication from 0.001, we were changing that to gigawatts. All right, so it doesn't matter. I'm just gonna say solar and wind. One of the cool things about scikit-learn is that it supports multi-output regression out of the box. I don't know if you know this before, but you can predict two things at once, and that's awesome. You don't need to do anything too fancy. It's just the same code as if you were predicting one of them. It's just you add one more to the y, and that's it. So in here, at the same time, we're predicting the solar and the wind power with the features wind speed, temperature, red horizontal, and red diffuse. I'm going to be using first the train test split with a random state of 42, so it's reproducible. I'm just going to be choosing 80% for training and 20% for testing. And this is the basic stuff you always do, okay? So you define your model with your regression, you fit it with your training data, you predict it with your test data, and then you calculate your evaluation matrix. So as you can see here, we have a pretty decent model. You have an R square of 8.4, sorry, of 0.84. You have a root mean square of 2.49 and a mean absolute error of 1.17 or of 1.17. So it's a pretty good model. It's not bad because we're not adding here anything fancy again, okay? So I'm not adding here, I mean, you could add here whatever you want, like cross validation, grid search, whatever you want. In this case, it's a very basic model I'm just creating here. Just to have an idea of how we did, I'm gonna be plotting two things. I'm gonna be plotting the predicted solar, all right, that is in the Y, and this is the actual solar. So we actually did a pretty good job of predicting because they do follow like a linear dependency, and we can see here that I'm just here painting by the temperature, by the way. Here the temperature is in Celsius degrees, by the way, and I'm just printing here the predicted values and the actual solar values. And this is the solar values. And this below here is the wind value. And in here, I'm painting by the wind speed. Okay, so I'm coloring this plot by the wind speed, as you can see in here. So you have the predicted wind and the actual wind. So good. So this is, I mean, so far so good, right? So far, mm, we've been seeing the basic stuff we can do, and this is what we normally do in machine learning. We always start with a basic model like linear regression. Let me close this now and go to the one called model RF. And as you can imagine, this is a random forest regressor. So I'm not gonna be again that detailed because I explained all of this in the past notebook. So I'm just defining the metrics, reading the data, defining my x and my y. Again, we're predicting the solar gigawatts and the wind gigawatts for that. We're splitting our data. We're feeding our model. In this case, it's a random forest regressor. Okay, with the default parameters. And now I'm gonna be again just showing you the R2, the MIE, and the RMSE. So it looks like we have a pretty decent model as well, and it's even better than the last one. Uh, we can say that because seeing of the mean absolute error and the R squared, we're seeing that we're capturing more variance, and also we have a lower error in general for each one of the predicted values. So this is a better model than before, and I'm just going to be plotting now again the solar and the wind. This is the same plot as before, okay? So this is the predicted data and this is the actual data. It follows a good linear pattern, and I am coloring by the temperature. I'm doing that for the solar data and also for the wind data, all right? So in here you can see the predicted wind and the actual wind, and in here I'm coloring by wind speed. All right, so we are luckily in a good path. Let me just run this before ending for the myth Q&A, and let me go to Keras now. So this is also common. Sometimes you get started with something very simple like a linear regression, and then you get fancy with a deep neural net. Why not? So in this case, I'm going to be using the Keras API from TensorFlow. All right. Remember that Keras is now part of TensorFlow. I'm defining here the metrics. I'm just importing our basic or basic libraries in here. And this is the same process, okay? I'm just defining my data. I'm just defining my random state in here. So the only difference from this code and the last one is that you need to set up the random seed for TensorFlow as well as the train test split. This is because TensorFlow is also doing some stuff underneath that are random, so you need to set a seed for that. So if you want to reproduce your models. So one of the cool things that Keras also supports multi-output regression, so you don't need to do anything fancy. Again, we're predicting here the solar and the wind power. Okay, so the idea here is that we're using something simple. It's just a sequential model of a dense net. Uh, by the way, if you have the chance to check John's session and I forgot the name, sorry, of the last one. Also on deep learning, those very good presentations on deep learning. So if you were there, you understand all of this. If not, let me tell you a basic idea. We're defining here one hidden layer as an input. The other hidden layer is also a dense layer, just taking care of some of the things here, and just a third layer here with just two outputs because we have two outputs in here. So we have like a you can say what one input layer, one hidden layer, and one output layer. But some people also say that these two are hidden layers and this is the output layer, right? So I'm just defining some layers in here for our model. We're going to be using the Atom Optimizer with a learning rate of 0.001. Again, I'm not trying to be fancy here with the models. This is just up to you. I'm just telling you how a model looks like in reality. Finally, we're going to be using the MSE loss for compilation, and we're going to be using the root mean square and the mean absolute error for tracking the errors. All right, in the end, we're going to be returning the model, and let me just define that, and this is just the idea of what we're going to be building, okay? So it's a model that is containing 1,282 parameters that are trainable, and we're going to be training that in batch sizes of 256. So if you want to get fancier here, you can go here to 128, something like that, and you can increase this to 100 epochs, whatever. This is just a basic example of Keras. You don't need to do something like all of this, okay? So this is just a basic idea of how to create a model in here. So it's running all of my. Okay, thank you very much. It's just running all of the epochs in here, and it ran. So we're happy with that. Now let me plot that so you see the loss, the RMSE, and the MAE. We're happy with that, and we're just going to predict, check our metrics. It looks like a fairly good model, not bad, not better than random forest maybe, but it's not a bad model. And I'm going to plot this and this. So you're seeing in here, what you're seeing here is the predicted data for the solar and the actual data, and also for the wind data. Okay. So with that, we're missing some very basic stuff for this starting point. And again, I'm not showing you anything fancy so far. I'm just showing you the way we normally work in data science. And there's a lot of problems in here that I'm going to be discussing after the Q&A session we have right now. Okay, so I'm open to questions at this moment.
Well, as Fabio said, we now have the opportunity for mid-workshop Q&A. Attendees, the idea behind this is to answer a few questions that might have popped up throughout the workshop. As I understand, Sam has been doing an amazing job in answering all the questions that have popped up through the chat. If you have any extra ones, or if you need any questions that require some visualization or some, well, I don't know, some screen time, again, you can send them over through the chat. We'll pick them up and we'll ask Fabio. Again, the way it works, you'll send the questions to the chat, I'll get them, and I'll ask them to you, Fabio. So attendees, send your questions. We can get started maybe talking a little bit something different from the workshop. How did you get started in this whole world of data science, Fabio?
It's an interesting question. So I got started by accident, actually, in data science. I was working in Venezuela. Anyway, I'm from Venezuela, if you don't know me. I started in there working in a company called Mood with a friend. And I started in the company to work in some back-end stuff. I was graduating physics. I was graduating computer engineering back then. But I mean, in the year before that, I was studying just because I liked it, some machine learning. So I had no idea of what data science was actually back there. I only had like a course with Jeff Leake in Coursera. I think a lot of you did that course with Jeff Leake and the people at the Johns Hopkins, where you were shown some basic stuff. And I also did in 2013. I did the course for Andrew Ng for the machine learning course. So when I started in this company, something happened that there was a project that for some reason was accepted by the company, and that project needed some information, some like to check for data and to download data and to process data and to work with data, and it was actually a big data problem. So I got started with big data, like a lot of big issues, like SQL was not working anymore, Excel was not working anymore. So we were trying to use something like R, but it was not enough back then. So I discovered Apache Spark. So Apache Spark was actually the first library I used to create a model for a company. So before working with scikit-learn or with R or Corret or anything like that, I started working like performing and creating models with Spark. And also back then we were using Scala for Spark because in the beginning the Spark API for Python was not that well. It was slow, it was not entirely documented. So we were using Scala, and I really thought Scala was going to be the future of data science back then. For some reason, it moved to Python. We all moved to Python, but I really thought that Scala was going to be the future. So yeah, in that project, I worked with some friends, and we had to create everything from scratch. We built a a cluster out of nowhere. So we just downloaded some of the packages for that, like Linux server and Ansible and Java and Mesos and HDFS and Hadoop and all of that, and we install it in some basic 4 gigabytes machines of RAM, and we managed to make it work. We didn't have the money to buy anything in the cloud, and there was not a lot of the cloud things you see right now for data science and big data. So in that project, I worked as a data engineer, data analyst, uh, data scientist, programmer, software engineer, and I think that's a lot of the cases for all of you there. That if you're trying with a small company, that's the case. But I think that's actually a very good opportunity. Don't get frustrated thinking, oh, I'm not doing modeling. I'm just spending so much time configuring computers. That's also something you need to learn about because when you are working as a data scientist fully, then you understand every piece of the process from ingesting the data to the idea of deploying a model. So that was my beginnings in data science.
Well, that's an amazing, amazing start, an amazing beginning and entry point to this whole wonderful world of data science. We have a question that I see that Sam just answered, but if you want to give in your take, feel free. Balan Chen asks, when we set Keras to two different metrics, does NN optimize on both metrics or individually?
So as Sam just happily answered, the one it optimizes on is what you set the loss to. All right, but you can record any number of metrics and log them over the epoch. So that's just the basic idea here. So Keras is just tracking the one you set, okay? But you can put it to you can say to it that you want to record a bigger number of metrics for your model, okay? So basically, we're just recording here the loss in here, but you can track more stuff in Keras. You don't just only need to track one of them.
Okay, wonderful, wonderful. Thank you. Now we have a question from Naman Sharma who asks, how is an assembly line different from pipelines?
Mm, One of the things we're going to be seeing that is very important is the idea of modules. When you have modules, we talk about pipelines because it's not just a random set of things happening at once. You're splitting the process in small steps, and each one of these steps is a step in the pipeline. Okay, so the combination of all of these steps in a formalized way is gonna give you a pipeline. Is Again, you need to define assembly line, something very similar, of course. But when we say pipelines, we're taking that concept from the words of scikit-learn. One of the pioneers of pipelines was scikit-learn. And the idea of scikit-learn was to divide the estimators, the transformers, the models, the data, all of that into different chunks. So when you combine all of them, you can have a whole pipeline. And Spark it's also like that. If you're using Spark, you know that to create machine learning models, you need to define pipelines as well. So because the people who created Spark also created MLflow, I think they're heavily based on the Spark API, on the scikit-learn API of modularization. Modularization is key if you want to understand pipelining, and this is why we're doing it here.
Well, wonderful, wonderful. Thank you so much. We have a question also coming in directly for you from Nandita Nandakumar. It says, "Hi Fabio, you're doing amazing work. What is the most challenging issue you have come across while building some of these pipelines for big data?"
So I think one of the hardest part is that everything. So I'm showing you here an example of something that could be happening in real life. But the thing is, every project is different. Every data set is different. And so to have like a formalized set of steps to solve any problem that does not exist. So I think to be able to understand the business problem, understand the data you have in your hands, and to be able to create a process that is transforming that data into value, that's the hardest part. And in the operational side, I think one of the hardest parts before showing what I'm going to be showing you is to track the models. Which one is in production? Which one is was the model we used last month? Which metrics are we tracking for our models? And to be able to express and deploy models throughout the company and also externally, that's something that's very tricky to do. So MLflow will solve all of our problems with one API, and that's going to be very interesting to do.
Okay, okay, great. Thank you so much. Now we have a question from Bruno coming in. He says, if I wanted to do ML ops, the best way to do it is with these technologies. I mean, with Airflow or MLflow or and Python, for example.
Yeah, so I don't know if they're the best tools, but they're one of the best tools we have out there. Right now, MLflow is the de facto framework for working in the ideas of ML operations when serving models, tracking models, and all of that. There are other ways of doing it. Okay, you can do this. We you even have like paid solutions to this. I mean, you can pay people. There are platforms that you can pay, like Algorithmia, Cloudera has something like this. And you have some stuff like are also open source, like Pachyderm. You have MLLibs. So there are a lot of different things, but I really see a lot of future to MLflow, and because of two particular things. The first one is being built by Databricks. Databricks is like the Google of data science. They're innovating a lot. They're creating amazing stuff. Okay, so they're working with a Spark. They have Delta Lake, and they have huge investors. So they have a lot of money to keep working in MLflow, and that's something you have to think about. MLflow is not just a random open source package. Even though it's open source and you can see all of the code in there, it's being maintained by the company. And that's interesting because you know it's not going to go away because they got bored. Some of the problems we have with open source that if a person decides to shut down a project, that's it. That's the end of the project forever. But if you have foundations and company on the back, you know it's not going to happen. Like Pandas is open source, but it's being helped by NumFocus and the Python Foundation for Software. So you know it's not going to go away. You know NumPy is not going to go away. So this is the same thing for MLflow. And the other thing I want to mention is that the community is awesome. There's a lot of people interested in this. So you have people from Spark, from TensorFlow, from PyTorch, from scikit-learn, from XGBoost. They're all, I mean, committers to those platforms are also committing code to MLflow. So I think you have the best of both worlds with MLflow right now.
Awesome, awesome. That is wonderful. I think that pretty much closes off this little tiny mid workshop Q&A. I hope everyone in the audience is excited to jump into the second part of the workshop, and I hope you, Fabio, are re-energized with all these questions and ready to continue going. And well, why don't we continue?
Of course. Thank you very much, Roberto.
Thank
So
you.
let's go ahead and continue. So we left in the creation of all of the models. Okay. Um, so now what we're gonna build is two basic stuff. So let me just do this and have this back again in here. So again, let me just go here. Where am I in here? Okay, project presentation. DSGO 20. Okay, so I'm gonna do now is that I'm gonna show you something that is very common, and is the word the ideas of reporting and the ideas of a dashboard. Okay, so if you are here in our starting point folder, I'm gonna open that again also here on my terminal. See here one. Here it is. You have the dashboard folder in there. So let me go to dashboard in there. And so if you're in the dashboard, you see that you have this is a dashboard. Okay, I don't have the time, sadly, to explain all of the things happening here in this dashboard. But in the end, we're going to be seeing our two plots. That's it. Dash is not that simple. Okay, so it needs a lot of different stuff. This is the actual app that is using a lot of HTML and JavaScript and CSS. This is just to load of the elements we created before. Okay, and the elements are here in components. So what we have is how to get the data, how to get the model, and as you can see here, the dashboard we're going to be building underneath has a linear regression model. Okay, again, one of the problems you can imagine in here is that this is not actually using the last model we created. It's just recreating the model. Okay, I'm not using here the model we created before. It's just I'm redoing the model to be able to use it. So this is one of the problems. We don't want to do that. I mean, it's gonna be it will be better if we could have the model in some place and we could take that model and just use it here. But this is not doing that. Right? So it's gonna predict with that model, and finally it's gonna be plotting some stuff. Again, I don't have the time to explain everything in here, but we're going to be using the data and we're only going to be predicting for 2016. Okay, so the dash model, to be able to run it, okay, so if you're here in the folder called dashboard, you say Python app.py and you click enter. Well, this will happen is that what will happen now is that you have to go to this exact URL in here, and this is the dashboard. Okay, so this is the dashboard in here. As you can see here, this is an average of the solar power production, okay, of Germany. Again, we're thinking on Germany in this case, from January to November for 4 years, 2013, 14, 15, and 16. Okay, and you are predicting in here the solar model and the wind power. As you can see here, this is working predicting just in 2016. As you can see here, I'm predicting from January to February. I can go up. Okay, let me say I want to go to March 2nd. So in here we have predictions from January to March. So this is again something that you normally do. Okay, again, this is just a basic dashboard. I don't have the time, sadly, to explain all of the code in the dashboard, but it's just, I mean, you have the code in your hands, you can mess with it, and you can try it on for your own project. So let me close this right now. I'm also going to close this from the terminal. And I'm going to go to a different process now. It's called the report. So aside from the dashboard, you may also want to have an HTML report or a PDF report that you can send as an email to your boss. Because maybe he doesn't understand the dashboard. Maybe he said, no, I want to have an email in my desk every day at 8 a.m. Right? So what you do is that this is what's going to happen in this notebook is we're going to do the same thing. Okay? It's almost the same thing, but now we're going to be predicting with Python without Dash. So I'm importing this, and I'm getting the data. Again, I'm using the linear regression, and as you can see here, we have another problem. We're not using the model we created. We're just doing it again. So this is very simple because this model run runs in like 2 seconds. But what if you have a really hard model that takes an hour to build? You want to build it over and over and over again every day, like click it and wait and all of this, and every time you fit it, you wait hours. So that's one of the issues we're going to tackle next. So again, I'm building a model, building the prediction, and this is just the summary that is just saying to the boss when was it generated and how much data is using to create it, and it's going to be predicting for just 1 week. No, for the current and the next week in here. So that's what we're trying to do here. We're creating a figure that we're gonna be having that figure that figure in there. This is the same figure as before, and we're gonna be just predicting the data from before, and gonna be making that same plot. So what's the difference in here? We are predicting the same stuff as before, but we're not using like a dashboard model. We're using just a notebook. This is the same code as before, all right? So you're seeing the same graphs, the same model, but now we're just using the dashboard. Sorry, we're not using the dashboard. All right, so now when you have this, you don't want to go, I mean, you don't want to send, I mean, you don't want to wake up every day, run this model, go file, download as HTML, and send it to your boss. What you will normally do is that you will build a basic Python file that will read the notebook, all right, and it will transform that automatically into HTML. For that, we're going to be using mbconvert, and that's it. This is just a very basic Python file to transform the notebook into an HTML. So in here, you go to dashboard and you click here. No, sorry, you go to report and you click here Python create report and you run, and that's it. You wait for some seconds. It's going to be executing the code below the model and everything. So if you go here one step before, in the output folder, you have the HTML. And this is the thing that we just saw in the notebook, but we're just seeing here the actual thing. You don't have any code in here. And this is what you want to do, right? You don't want to have any code in here. So there are some options that we used in the notebook and and also in the Pythons that will strip out every code, and you will only have the markdown and the actual figures. So again, what have we just been doing in this past hour? We've been working with a lot of different things that are normal to do in data science. And now what we're going to do is to transform all of this into the world of MLflow. So you can see, because we have a lot of problems in here. The report was using a model was not the same as the dashboard. The dashboard was using a model was different from the notebooks. It's not easy to track the models. You don't even remember which one was the best. I mean, you could think on opening an Excel file and just saying, okay, first model, I ran it at 7:21 p.m. and on Sunday, and that's it. And so these are my trackings. I track the R square, I track the MIE and the RMCE. So you're doing it by hand. That's not something you want to do. You want to have a system that will automatically capture your models and all of that. So for doing that, we're gonna go to the repo again. Okay. So this is gonna be fun now. This is where the fun starts. Okay. So let me go and tell you something that I think it can help you to work better. So if you are in your if you're here presentation DSGO 2020 and you go to DSGO pipeline, uh, I'm missing something here. Where's this? DSGO pipeline. So let's go to the folder number 2. All right, and in folder number two, you have all of these notebooks in here. But this is important. Before doing all of that, I'm gonna be running again that piece for SQLite. And I'm going to tell you why. Sometimes if you create the folder in your home folder, it won't track it. Sometimes you need to have it inside of where you're working because so it works. And this is something that you can work better with better practices. But in this case, for the sake of the presentation, I'm going to be replicating sometimes the SQLite database. So it's easier for you to see how I'm doing it. So we're gonna go to the to here again, and I'm gonna run the same code, okay? So I'm gonna copy all of this, okay? And I'm gonna be copying this thing in here, okay? And I'm gonna be saying here ML runs, and I'm gonna click enter. So what this is doing, okay, and as you can see, it stopped there. Okay, it actually did something very interesting, and I know it did. So right now, let me keep track of the terminals. Okay, we have one terminal for Jupyter, and if you did this exactly and directly in the second folder, you will have something that looks like it's jammed, but it's not. Because if you go here, okay, to the second folder again, you see that you have created the folder mlrun, and also you have the database for SQLite. Now, if you open localhost 5000, okay, as you can see in here, this is the UI for MLflow. In the next in the following hour, we're gonna be working with this UI to interact with everything in MLflow. Okay, so again, just how did I get there? If I run this directly on my folder, second folder, and in here you don't have to put Sam Ray, of course. This is Sam's folder in his computer. You don't have his folders. You need to change this to your actual name in your computer. If you're using Windows, um, yeah, so I recommend just running that entire code snippet more flow in your home directory, and you can keep it up running. Okay, yeah, so that should work as well. So Sam is saying here that we could just run this directly in the home folder of my computer, and that should work. But Sam, something interesting that's happening to me, that if I don't do it like this, I have errors. So the thing is, this is I know that the idea is to put it directly in the home folder, but for some reason for me it works much better if I put it directly in the folder that I am creating the things here. So again, this is not the best practice ever, and I'm aware of that. But in my computer, for some reason, there are some errors if I just have that one in the home folder. I already have that one in the home folder, but for some reason, when I track the models, the only piece that's not working for me, and this is something that we're just being clear here, me and you. Sometimes the artifacts, when you're trying to log the models, is not working. If I had the folder only in my home directory, it worked perfectly for the tracking of the metrics, but it didn't work perfectly for the models. So this is why I'm doing it like this, okay? And so let me continue here now. If you want to open at any time the MLflow UI, you have to click MLflow UI. You have to click that, and you can, if you want, export that URI directly to the computer. Uh, it's interesting, Sam. I know. So this is why I'm gonna work like this. Again, I'm just a recap from what I'm just saying. I'm having some issues with just putting the SQLite database in my home folder. It works better for me if I just put it directly in the folder I'm working. It's not the best practice ever with MLflow, but because we don't have the time to tackle all of the errors that I might get if I do it in the home folder, I'm just running it like this. Okay, so at this point, you should have open the notebooks and the MLflow UI. Okay, So let me go now and try and let us now understand the project and the idea here. By the way, there are great slides and presentations by the same people at Databricks. So they have done a three-part workshop for MLflow. So if you have like a want to have like a more explanation, like the theory behind MLflow, I recommend you watch this and the slides. Not right now because we won't have the time. But what we're gonna do is explain better, with more detail in those. It was like a 3 hour workshop they did for Everflow. So that's what we're going to try to replicate here for our example. Great. So let me go now to the second folder, okay? It's called ML tracking, and the idea is I'm going to go now to the first one, model linear regression. Okay, so let me explain you how this works. As we say here, we're going to see how simple it is to log metrics and the model. All right, so how this is going to work? We're going to be importing our libraries. We're going to be setting tracking the URI in here. So set tracking URI to here. All right. This is just in case you didn't set the ML4 tracker URI, so you don't have any issue. So I'm going to be run this right now. And now I'm going to be creating an experiment. And this is something important in MLflow. You have experiments. Okay, and that experiment will contain different models. So one experiment can have, so you can think of an experiment like a project. Okay, so each one of the experiments will contain different models that can go to production or you can work with them, whatever. This is just setting up the project. So I'm gonna call that predicting wind and solar. I'm gonna be defining the metrics as before. So it's telling me that this does not exist. So it's gonna be creating a new experiment. How do we know if this worked? We go to the ML flow and we refresh. Okay, if we refresh, we see we now have something below here. It's called predicting wind solar, and this is just happening from this notebook. Okay, so what I'm gonna do is that I'm gonna be reading my data as before. Nothing has changed so far. We're gonna be predicting again solar and wind. Nothing changed so far. Train transplant, everything is the same. And now to the funny part. We're gonna be starting a run. A run in this case is where we define a model in MLflow. For our case, we're gonna name that LR for linear regression. Okay, so and all of the artifacts created by this code that I'm gonna explain right now are gonna go to the Actifar URI that is gonna go here directly. Okay, it's gonna go here directly, and also to the SQLite database. So I'm gonna be define. So what's changing right now? Okay, I am defining my model and everything below here with mlflow.starRun name are two dots. So all of this is inside this with mlflow star run, and this is the way you start a run in mlflow. So nothing before that was different. Okay, the only different thing was setting up the experiment in the tracking URI. All of the code was the same. Now we're gonna be defining the model, feeding the model, predicting, creating our metrics, printing our metrics. This is just the same code as before, all right? This in here is the same code as before. What is different now? We're gonna be logging our metrics, or root mean square, or mean absolute error, and our R2 score. And also we're gonna be logging the model. So we're gonna be tracking all of this in MLflow. And also we're also gonna be tracking the figure that is the final figure, plotting the predicted values and the actual values. So if I run this, it's telling me where are my code going. So it's going to run one, all of these things that we're going to show soon. You have here your metrics, and finally you have this plot. If you go to MLflow URI again and you refresh, you see here that you have something different. You see, you have here, I'm sorry, you have here your start time, you have your user, and you have MAE, R2, and RSME. So if you click it in here, you see that you have your information perfectly here. This is your metric. If you click on the mean absolute error, as you see here, you have your metric. Is it being stored in here? All right. Let me go back now, and you can also see your R2 square, um, uh, or your R square, and you also have your model. And this is the funny part. If you click on model in here, you have created three files. So let me explain you how this works, or how this is doing right now. So let me go here now to ML runs. Okay. So this is the folder. This is the thing I created with that code. If I go to one, if I go to this thing here, I go to artifacts. I'm seeing the same stuff I'm seeing in here. Okay. So this is just a replication of what I have in there. So you have something called the ML model. And what is this? This is a file that is telling us this is a model, that the data is pickle as model pickle, the environment is the YAML that I'm going to show now. And you have the Python version, and you have more information about that specific model. So this was created automatically, telling me more information about my model. The conda YAML is just telling me what this thing used to create my model. So I use Python, I use scikit-learn, and with pip I use MLflow and Cloud Pickle. So these are my dependencies. So this is awesome because now we know exactly what is needed to run this model. And this model pickle here, I cannot access it because this is a binary file. This is the pickle storing our data and storing our actual model. All right. You also have the file for your the predicted against actual values for the solar wind. Okay, so this is awesome because we're tracking stuff in here. If you create a new model, okay, a new version for this, it will run a new run for this experiment. So in the experiment, we'll have different models, and and those models can have different versions. Again, we're going to see this better in the next notebook, but so far you see that we have been tracking very easily out of different things we have. Okay, cool, great. So that now that works. I didn't mean to close the URIs here. So let me go again to MLflow, installer. So this is our very basic model. I'm gonna close this and I'm gonna just shut down the linear regression. And now let me go to random forest. As you say here, we see also how can we log the model parameters and how can you have multiple runs in a single execution if you want. So far we only have the linear regression and one model for that. So let us go now to random forest. So we have the tracker URI, we set the experiment, and as you can see, because we have the same name in here, it's gonna be happening inside of this. If you put a different name, even by a letter, it's gonna create a new experiment. Okay, so you sometimes you want to do that, sometimes you want to have all in the same experiment. Okay. So you have the evaluation metrics in here. All of this is the same. You read the data, you split the data, nothing has changed. And now, this is going to be a nasty brute force hyperparameter search, okay? So the idea here is that you should be doing this by something more complicated or more fancy, like k-fold cross-validation or stratify k-fold cross-validation, grid search, whatever you want. This is just an example to show you how can you have different runs in the same experiment. So in this case, we're going to be searching or grid of parameters with some estimators and with some max depth. So we're just changing the parameters in our model. That's what we're doing right now here. So these are hyperparameters, by the way, not parameters. They are hyperparameters, so they need to be optimized by something like grid search or cross validation. So we're using here as an example the max step and the estimator. So this is a nested for loop that inside of that has the ML flow code. Now we have a different name. We have RF from random forest. And inside of that is the same process. Define a model, feed it, predict, define your metrics, then you print the estimators and the depth and the root mean square, and you now are gonna be logging not only the metrics as before, as you can see where we were using log metric, now we're using log param because we're gonna be also logging the number of estimators and the max depth. Okay, so and that's the idea here. We're gonna be also tracking the model. Right, so let me run this. This is gonna take a while because this is gonna run the estimator. So for 4 estimators and max depth of 2, that's the root mean square. For 9 estimators and max depth 10, so it's gonna do it one by one because again, this is brute force hyperparameter search. The last one that we took care here was the 64 estimators and max depth of 10, and that got us a root mean square of 2.25. Again, I'm just gonna plot here the solar with the actual and the predicted, and the wind actual and predicted. This is the same story as before. So the actual change was in here. So now we have this. Let's go to the UI of MLflow. Nothing seems to be happening, so we refresh it, and here it is. Here's the magic of MLflow. So what you're seeing in here is each one of the runs. This is awesome because we know now that in particular a run with a max depth of 10 and a number of estimated of 64 will produce a mean absolute error or 1.46, an R2 of 8.x7, and so on and so forth. So if you click on each one of these models, you see here the tracking of your MAE, your tracking of the model in it itself. Okay, we don't have a picture here or a figure because I didn't track any figure in this case. So we have the Conda YAML, the actual model as a pickle, and we have the ML model. So far so good, hopefully. As you can see here, we're tracking also the parameters in here. And we're tracking the max depth, we're tracking the number of estimators. So, and we have more information. It was launched by a kernel in Python by Favio Vazquez, that's me. How long it needed to run, and the exact date and hour that this was run. So this is a great way of start tracking your stuff. It's no longer the case that you are blind of when you created a model to for which parameters. You don't need to open 4 Excel sheets to have a tracking of all of this. It's all being done by you. Uh, for you, I'm sorry. So everything looks great in here. And now let me go to the final step in here with the modeling. And then we're going to get see more information. And in the third one, we're going to use Keras. And with Keras, we have something very cool. It's called Autolog. With only some libraries have. Right now, they're working in a pull request for PyTorch and scikit-learn. So as you can see from before, if you want to track the metrics and if you want to track the parameters of the model, you need to say that specifically for scikit-learn. But as we could see for Keras, it's gonna be much simpler. Let me tell you why. So this is the same stuff. So when a library it starts to get boring, that's the best library ever. When you know exactly what you're doing and you're not thinking, oh man, this is Keras now. What's gonna happen? When you're just being familiar with a library and it's a simple API, you know it's a good library. And this is the great thing about MLflow. We're not changing our code that much. It's just a simple changes we're creating here, right? So again, eval the metrics. We're gonna be reading the data, setting the random seed again, and also splitting the data. This is the same as before, okay? If you remember the Keras models before, this is the same stuff. Now we define a model in a function. This is the same exact model as before, okay? And the difference now is that we're gonna run it with MLflow. We're gonna be testing this for two type of batches, 128 and 256, and this is gonna go exactly here in the fit. When you set the batch size for the epochs, you're gonna be testing here two. So we're gonna have two runs. So now you know because we have two parameters here. We're gonna be tracking here two runs. And so this is the awesome part. Okay, so you say with MLflow, this is the same as before. Now, instead of writing exactly, okay, I'm gonna be tracking the mean absolute error and the root mean square and the R2, and I want to track also the number of epochs and the number of batch sizes. You just say mlflow.tensorflow.autolog. And every iteration, what it's gonna do, it's gonna track that. It's gonna track every parameter possible. So you don't have to write anything. You have to say autolog, and that's it. You're happy with it. You have here again. This is the same stuff. You have your predictions. You have your metrics, and you run it. So this is gonna run. Okay, this is gonna run 2 times. Okay, because you have here for 128 batch size and 256 batch size. Okay, so this is running 50 epochs per model. All right, so this is gonna be ending in just like 5 seconds. Okay, so hopefully this works. Okay, so now I'm just gonna plot it. Okay, so this is the same as before. Okay, this is the same as before. We're just tracking the loss. We're tracking the RMSE. We're tracking the mean absolute error. We're tracking everything in here. All right. So that's what we're doing. And now we're gonna plot here the actual and predicted as before. And now for the funny part, let's go to MLflow, refresh, and here we go. We have our two Keras model here in our eyes, in front of our eyes. Let me click to the last one in here. So if you click there, you see that you have the batch size, the epochs, what was the optimizer, and more things like the beta, the decays, the epsilons, the learning rate, the name of the optimizers. You have all of the metrics, and we didn't write any code for this. This is amazing. This is awesome because we are also making our code smaller. And this is awesome because whenever you have the chance to code less, go that way. Go that way. All right. If you're a programmer, you know what I mean. Um, and you also have the model summary. Okay. So this is you have an idea of what you're building. And now you have the tensor board logs also for the training and the validations. So you can log this if you want into TensorBoard. I'm not gonna do that, but you can log this into TensorBoard. You have that for the training and for the validation, and you have your model, okay? And you have here your model where you also have the model.h5. This is the actual model that you will get from the h file library to then deploy it. Okay, so you have the ML model, the conda YAML, so everything is the same. So far so good. Hopefully for all of you, we have been testing one of the great stuff about MLflow. As you can see, it's simple. It's very well done. Okay, so let me close this now. And in the presentation, it says now that the idea is how we can compare our models, okay, outside and inside of the interface. How can someone reproduce the exact run as you did before, and how can we pick a model to serve? So that's what I want to build right now. So let me start by comparing the models. So this is something very interesting. So let me go now into the compare runs, and I'm gonna do that with the notebook. Okay, you can also do that in the UI. I'm just gonna do it in the notebook because it's simpler to do here. So I'm gonna log MLflow, and I'm gonna track in I'm gonna set the tracking URI in the experiment so it knows I'm working exactly there. If I click now on search runs, as you can see here, it's telling me which runs are there. So what are these things here you can ask? These are our linear regressions, or random forest, and our keras. It's they have a lot of things here, but if you go to the run name, you understand that this is linear regression, random forest, and keras. So now you know, and you have a lot of information in here. You have the number, so you have the actual parameters. You have more metadata about who ran it and when and stuff like that. Let me now select only the runs with Kera. So you should have two here. Okay, and I'm gonna print the metrics and I'm gonna print the parameters in here. So what I did is that I know we have this like pandas file here with all of this material. I just want to get like the gist out of the keras models we created in here. So in this case, I'm just selecting the first model. It's telling me that the loss, all of the different metrics, is telling me the parameters, and this is for one model, okay, and this is for the second model. So in this case, we can compare with our eyes which one is better for you. And again, you should know more about deep learning before trying to do this blindly. But if you know keras, you know what I'm talking about. You can also go one layer down, okay, and this is awesome because you can get the client. So the ML Flow client, you're getting like a snapshot of this web page. Okay, so you're getting everything in there, and in there, I'm just looking for the loss metric, and what I want to do is I want to plot how was the change in the log metric in all of these steps and the epochs. So you have all of these things here, and that's what I just did in here. So I'm just going through the client, downloading some data for the metric story, and then I'm just plotting that with Matplotlib. So hopefully you understand this, and this is the idea of comparing the runs. Let me just close this now, and let me go now to the final piece of second one, and is how can we promote a given model into production. And this is one of the parts that are that I think can be interesting for you, and this is gonna take some basic steps, but let me just do it one by one. Okay, so the first thing we want to do is that how can we start thinking about putting a model into production? Okay, so the first thing to do this is go to the ML flow. Okay, let me go to the ML flow thing here. So I have it here. So the thing that I'm going to do is I'm going to find the best performing algorithm. So I am assuming in this point that you have explored all of the models you created, and what you have now is that you know what is the best model for you. Okay, so you know what is the best model. So let's say we want to pick the model with the minimum mean absolute error. That's an example. That's something that you can do. Okay. So what you do here is that, so I'm gonna go and let me try to select this random forest model, okay? So I'm gonna be selecting the random forest model with the max depth of 10, the number of estimator 64, and that has these metrics, and this is the model, okay? So the thing, this is the process of how this goes. You choose artifact, okay? This is the model, and you click on register model, and you're gonna be clicking here, and you're gonna go to create new model. Now you're gonna say this is called best model. This is the best model for you, and you're gonna register that. All right. When that happens, you're gonna click in here. So you have like a click in there, and you're gonna go here. This is all of the models you have. A different way of accessing this is you go to localhost 5000 hashtag and models. If you click here, you have all of the models that you have defined in here. So these are your registered models. Remember that we were talking about the model registry? This is that place, okay? So if you click on, okay, thank you very much. So if you click on there, so this is what you have, right? So let me follow these steps. So now that we have registered a model, now that model is registered. So we can move that to staging or production. All right, so what's the idea here? If you are a machine learning engineer, if you are a data engineer, you understand about continuous integration, about the work of continuous delivery. So you want to be changing these models into staging. Okay, let me work on this before actually going to production, or let me just go and put this into production, or let me archive this model. So how to do that in here? Okay, so you click on the version of the model. Let me do it again. You have the models in here. You click on the name. You click on the version, and in here you have the stage. Before that, you also can add a description. Okay, you have here a rich text editor. You can say, "Hey guys, this is the best model I've ever created. Let's put it into production." Into production. So everyone who has access to the MLflow UI can see this and understand what this is happening. Again, you will not put this, okay? You will put here, I created this model with this, and this, with these assumptions. This is what I did. So a whole description of the model. So the normal way is that you will put this into staging, waiting for the data engineer to approve it. By the way, you have a different version of MLflow if you're working with an MLflow server in in a more advanced system where people can accept or deny your proposal to change a model. In our case, we have like admin privileges, so we can move directly our model from non to staging or production. But you can set up this in a way that only one person in the company can put a model into production. And that's something that you should think about the governance of the data, the governance of the models, and stuff like that. So, so don't worry about that. Let's put this into production directly. So, transition, okay. So now, if we go to our registered models, it says that this is a production model, okay? So we have that into production. So now, let's just go to the file called get prod model. So hopefully you have been following me so far. So what I'm gonna do now is I'm gonna be reading that exact model. Okay, so let me run this, and what it says here with this code is reading the best model that has to be in production. Okay, so you can change this into staging or whatever you want. In this case, I'm just going to read the best model that is in production. And you have the source in here, and you know exactly whether model is in our SQL database. So again, this is our SQLite database, but this can be in Azure or a bucket in AWS or whatever you want. Okay, so this is a local thing, but you can put with almost no change in the code this into any cloud you want. Great, so now let me load that model, and this is something amazing. Okay, so we say model equals to mlflow.python.load model, and this is, we're extracting everything from mlflow. We're extracting the actual model, the parameters, the hyperparameters, all of the instructions to reproduce this model. So if you do that, you remember this is a random forest model. And that's it. Now you have a perfectly good model to predict. Now what we're going to do is that we're going to be reading the data, and I'm going to be predicting with the model I just created. So I'm going to be predicting, and I'm going to be plotting. If it's not showing, I'm going to do it again. So this is amazing. We have created a model, and we have that model into production. So if that you can give this to someone that's not an expert in data science or machine learning, and say, hey, just run this code and you'll have the model in your computer. And that's awesome because they don't need to download the data and process the data and create the features and fit the model. You can give them like a structure of code so they can load the model and predict with it. This is an amazing thing, and this is not going to be any change if you have Keras, Scikit-learn, TensorFlow, PyTorch, XGBoost. It's going to be the same Python.load model, and that's it. That's awesome because you don't need to think about how to change this code if you have different libraries. Okay, so hopefully you're being understanding this so far. I'm gonna skip one piece, and I'm gonna skip this part here where you can just serve this model in here directly with the computer, and then you can curl to it. Or should I do it? Okay, let me try to do that because I'm missing out of time, and we have more things to cover. But let me just do this right now. So as you can see here, the model we have is this. Okay, this is the model we have. So I'm just gonna copy this code in here, and what we're gonna do in this case is gonna serve that model. So I'm gonna copy all of this code in here, and now I'm gonna change the where is this? Okay, I'm gonna change where that model is stored. Okay, with this. So I'm just gonna delete all of this. So I'm just gonna change because this file is Sam's file, okay? Because he is having there the name of his computer. So now I have my model directly, and I click run, and everything looks great, and our model should be in 8003. So localhost 8003. So nothing is here, but it should be something in there. So let me just try to call that model. Okay. So I'm gonna copy this code in here, and I am in here right now. So let me copy that and run it, and this is it. So I know it doesn't look. Let me put this in like big stuff here. So what we're doing here is that we're doing a curl. So we have our model right now as a REST API, and this is super awesome for data science, because if you have a REST API, you just need people to know JSONs, and that's it. So we're saying to this is the data we're passing in here. So wind speed is 2, temperature is 20, right horizontal is 100, and right diffuse is 100. And we're gonna and when we run this, we get 4.85 and 1.166. What is this? The solar power and the wind power. So with that simple piece of code, we have just put our model into a production to our REST API without caring about anything else. Okay, so let me just stop this right now, and this is hopefully the model we have in here. Yep, so that is the model we have in there. So that model is no longer serving. If I run this again, I'll have an error because I ended the connection. So the model is not longer there. So what will you do? You put that into your server and as a recipe, and that's it. So let me go now to something important. If you go to the get production model, there's a piece of code in here that you should think about, and this is this piece of code in here. If you read your model like MLflow client, get latest versions, model name, and the stages, this you can get the best model, and you can put this piece of code in your report and in your dashboard. And with this, we have fixed the idea of running the same, of creating the same model over and over again in the dashboard, in the report. So now we have everything in one place. Okay, so everything is in here. Everything is in the MLflow. Tracking URI, so we're just getting the best model and putting that into production. Great. So one of the final steps we're going to be working here is to turning our steps into an independent project. So the idea here is that whenever someone, I mean, if you don't want to install everything, and you don't even want to send them all of the data, sorry, not all of the code to create stuff and that, but you want them to run the project for themselves, you can create something called an MLflow project. So let me just close this notebook in here, and let me go now to number 3. And in number 3, we have something called the Keras standalone. Okay, and what is this? So you have the Conda YAML. What is this Conda YAML? As you saw before, this was just all of the dependencies. When it says channels default, it's just the defaults for Conda. So you have the dependencies, you have the pip, and this is the dependencies for running your project. You also have the ML project itself that is saying to you Keras model. This is the name. The environment is Conda YAML, and this is the thing we'll have to change. The entry point is going to be a command, a command. And this command will be model Keras. What is model Keras? Is this thing right here. I just extracted the piece of code from the notebook that created the Keras model, and I'm just putting it here. Okay, So in this case, this is the same as you've been seeing before. You have your metrics, you define your data, you split it, you define the model, and you do a run with the name Keras and with the autolog and all of this, and you're tracking in here the metrics and all of this. Okay, so now what people have to do, and this is the interesting part, if they go here to your project, what they have to do is something like this. Okay, so you are in step number 3. All right. So in there you have all of this information, care standalone, and in that you have all of this, the conda, and you need the data in there as well. It's a good practice to put the data inside of your project. Okay, um, you need to replicate the data into your project. That's one of the best things. If the data is super huge or something like that, you can put it like a read for someone else. But the best practice is to put the data exactly where the model is, the project is. So let me copy this right now. All right, and I run it like this. And you wait for a second, and what this is going to be doing is going to be running everything in the project. You see, it's running the model for me. It created the data. It did everything. It succeeded. It worked. So now if you go to ML Flow here, so one of the things here is that for this is actually tracking. This is one of the tricky things. This is actually tracking only my folder in the second folder. And this is one of the issues I have with this thing, Samuel. So I know you're there. So if you want to see the results of this, you need to open the UI for the next for the for the third one. Okay. So if I this is the one for this the folder 2. So this won't be happening if I will have only one ML runs in my home folder. For some reason, for me, it didn't work, and I'm just passing the knowledge to you that could happen in Mac. I don't know why. So if you want to see the results of that, so I just closed my ML Flow UI in there. Okay, I created a different one in here. So I say ML Flow UI. I also replicated the project in here for the ML for the database in here. So if I say localhost 5000, I have the predictive solar model and I have the Keras. So this is the Keras model. Okay. Okay, so this is the way it works for me. Hopefully you don't have this issue that I have right now. This is not a good practice. The good practice is to have everything in one folder, in your home folder, or whatever you want. For me, it didn't work like that, and that could happen to you. So it's good we talk about this. We're being honest with each other, and so you know that this could happen to you. All right? Okay, great. So that's the idea for projects. And one of the other amazing stuff about projects is that you can put that into a GitHub file. So if you have a GitHub repo with only a project, you can say something like MLflow, this is it, run GitHub, and that's it. You don't even need to have the project in your computer. And this was explained in the workshop by these people at MLflow. And let me see. So here it is. This is the process if you're running this from GitHub. Okay, so you have the run, you run it in here. What it's gonna do is it's gonna fetch the GitHub project, it's gonna create a conda environment and activate it. It's gonna install the packages from the conda YAML, and it's gonna execute everything you need. So this is awesome because this is how you work it. So the way is you create one and you populate your entry points in there. You create a content YAML, you put your dependencies in there, you put your artifacts in there. And normally what you do is you create a model, a GitHub repo for that, and then you just test it with just run git and that's it. So you don't even need to do it locally. You can just say to someone, hey, I have all of the things in this GitHub repo, just run mlflow dot run git, and that's it. And this is awesome because that's an amazing process. Thank you. So the final step in here is how to put this all in Airflow. And I'm gonna be just very fast right now. Airflow is just a platform where you can create scheduling jobs. Okay, and you can schedule all of the jobs and have a DAG with this will happen and then this will happen and so on and so forth. Right now, let me just stop this right now. I'm just gonna stop this again in here. What I'm gonna do and what I'm gonna show you is how to create a very basic Airflow example. And Airflow, what it's gonna do, Airflow right now, it's gonna help me build the DAG. And this won't happen in the future of MLflow. As you can see in the repo, they're working right now in the creation of DAGs. They don't have that now in production, so we have to use Airflow. So you have to follow the steps here to install Airflow, to you and because it's not part of the requirements files, because this um, may not work for you in Windows. I'm sorry if you're using Windows, that could happen to you. So the idea here is that let me just go. If you go to the folder number 4, it's called Airflow. You have Germany and you have the MLflow DAG. Right. So what you have to do is that you have to init the database from Airflow, create the web server, and what you have to do is that you need to define a new DAG, and that will have to go inside the Airflow folder. So what I did is that if you go here to my computer, I am in my folder core Airflow. This is in my home directory, and in there I have my DAGs. And my DAG contains Germany and MLflow DAG. I'm gonna do it, okay, for you, and then I'm gonna explain you what is inside of that DAG, okay? So right now, what I'm going to do, that I'm gonna, you're gonna need to have several things open at this point, okay? So the first thing I'm gonna do is that I'm gonna go here to this tracking, and I'm gonna start here MLflow UI here. So I'm starting this in the folder number 2. So if I go to this, I have I okay. This is why it's not happening. Okay, so let me just run this again with the server and all of that, the SQL stuff, localhost. So this is my predictor installer. So I have all of this in here. Okay, so this is one of the problems I had with working with this thing. A DAG, by the way, is a directed acyclic graph. It's a graph that has no cycles, and you have lines. You have lines that has a direction. When you have a direction and you don't have any closed cycles, you have something called a DAG. It's normally used to express processes. I just need 2 minutes, please. I know we're out of time. I need 2 minutes, please. Okay, so I started this. So at this point, if you want this to work for you, you want to have open your notebook, your UI from MLflow. You need to run now Airflow initdb initdb, and this is gonna start the Airflow experiment in MLflow, okay? And it's also gonna start the SQLite stuff with Airflow. Now you need to have the Airflow web server. You need to put here Airflow web server, and you need to have this open right now in here. So that's gonna be importing the DAG from where you copy it, and you need to follow the steps in here. What are the steps? You create an Airflow folder, and you're gonna be copying everything that is in the folder number 4 of the repo into that DAG. So when you do that, and you have all of that in place, you have to run. So by this point, you should have run the init database and the web server, and you need another one. You need to right now Airflow scheduler. Okay, a scheduler. So far we need to have all of these open if you want this to work. Okay. So again, the notebook, the MLflow, the this is not something that's open, but you have to run the init database, the web server, and the scheduler. If you have done all of that, and this is stated in here, okay, in the folder, you should now open the Airflow web server, and that is in localhost 8080. 8080. Here it is. So this is my Airflow UI, and then you go to the DAG. And what's the idea here? You can test each one of these steps one by one. So let me go now to the actual code. This is very fast. In the code, what we have here, all of this is the same. The only different part is the DAG creation. So you have the evaluation metrics, and the first task is to create the data. All right. So in here, we're creating the data from Germany. We're making a linear regression. Okay. In this case, as you can see here, we're gonna be also tracking this into MLflow. This is the code you've been seeing so far. We're gonna be creating a linear regression, a random forest, and when we've done these two ones, we're gonna be getting the best model. Okay, we're gonna be getting the best model, and then we're gonna be registering. We're gonna register that best model, and this is the thing we did by hand. Okay, we're gonna do it here with the code, and finally we're gonna be setting the track of the URI, setting the experiment, and this is the interesting part for MLflow, for Airflow. Sorry. We're going to be creating a DAG that is going to be containing all of these steps. And all of these steps are going to be added with the Python operator. So I'm going to be adding the process, and you say what is the function to be called, what is the DAG, and what is the context, and you do this for the model, linear regression, random forest, and the best model, and the register. So you do all of this, you put all of these things here. That is to put the tax process to the linear regression. That's how, because you need to wait for the data before running the linear regression. Also for the random forest, and the best model needs to wait for everything before to run. So when you have all of this defined, you can run this directly in here. Okay, so you can run one step directly, or you can trigger every single thing in the DAG in there, or with the we're going to use it with the UI button. Okay, so you go here and you go to the DAG again, you put it on, you go to the DSGO, you go to the graph view. For some reason this failed for some reason. So let me just try to run it again. Let me just run it. So to run this, you go here to trigger the DAG, and you say trigger. So this is gonna trigger everything in here. So if everything worked, you're gonna be processing the data, creating the models, getting the best model, registering the best model, and doing all of that. And you will be also seeing this in the ML flow. As you see here, we have the airflow in here. So when that happens, you should have all of the things here. Okay, so you should have everything in here when it runs. So I don't know if I will have the time to wait for this to run, but in the final theme, so all of these things that it's gonna happen in this space, it's gonna process the data, create the models, get the best models, and then it's gonna register the best models. Okay, so you're gonna be okay. So the process data worked, so that's going well. So I think I'm gonna stop now. So this is gonna be working in the back while while I'm answering your questions. And this is the final step. The only thing that I didn't have time to cover is that if you go to the final folder, the evergreen dashboard, we changed something in the components. If you go to the elements in here, you see, if you remember before, the model was just creating a model in here. Now we're using MLflow to get the best model, okay? So that's the only change we did to the dashboard. And in this case, you're getting the best model. We're not creating a model in the dashboard. We're just extracting the best model from MLflow. And I mean, to run this, you need to have run everything before, okay? Because you will need to have the best model and the stages and all of that. Yep. So this is running in the back while I'm answering your questions. Okay. So you can go ahead and ask any questions you want.
All right. Well, wonderful, awesome. Thank you so much for that very very thorough workshop, Fabio. And I know that Sam has been working super hard behind the scenes and on the chat answering a lot of questions. But as for now, I'd like to welcome you to your very own DSGO Live Q&A. The way it works is attendees will send the questions through the chat, I'll receive them, and I'll ask them to you. So, attendees, you know what to do. Send your questions through the chat. We have a first question coming in from Ayub. He asks, what metrics could you suggest me for a recommender system, additionally to accuracy, recall, and precision?
So for a recommender model, you can actually use some of the metrics we have also for regression. So you can also measure something like the mean absolute error and the error or the root mean square for models like ALS. If you're working with something like ALS, you can work with all of the things we are working with regression. And if you go to the documentation for ALS in Spark, I think it's one of the best. You see how they're logging their metrics and how they're using the ones for regression to work with this as well.
Okay, well, wonderful. We have another question now from Sergesh. He says, storing data will be infeasible for data stored in data lakes, such as Snowflake, Redshift, or Delta, and big data kind of Spark model. Any alternatives?
Of course. So as I mentioned in the beginning, this will cover and solve some of the problems. One of the things that this is not the best for is for tracking data. It can do that. By the way, if you're working with me in the process, this has the DAG for Airflow worked, so I'm happy with that. So it worked perfectly. So if you are there yet running, so for me it worked. I'm seeing it here in my screen. So going back to the question, there's an alternative, and that alternative is called DVC, or Data Version Control. That's a library by the people at iterative.ai. I actually know the creator is called Dimitri, and I have 2 articles on DVC on how to track data, even if you have big data, even if you have terabytes of data, DVC can work for you. And I think a combination between MLflow and DVC, it's awesome. Because with DVC, you can track everything related to the data, everything you want. If something changes the data, and you can have pipelines for data. So the things we did here for modeling, you can have that for data in DVC. So I think a combination between DVC and MLflow is going to be awesome for your specific case.
Okay, wonderful. Thank you so much. Now we have a question coming in from Pavan. The question is, does MLflow work well with streaming data, especially using the Airflow scheduler?
Yeah, so it worked perfectly with Spark. So I didn't show anything about Spark because I didn't want to have the time. I didn't have the time to explain what Spark was if you don't know Spark. But Spark has an amazing streaming library. So if you do have streaming data, MLflow can work for that. By the way, I think the recommendation from them is kind of biased because they're actually trying to sell you something called Delta Lake. So if you have Databricks environment and you buy something called the Delta Lake, that creates a whole environment for streaming data, and that can work with Everflow perfectly. If you don't have Databricks, and by the way, you don't need, all of what I showed today is completely free. Okay, you don't need to use it in any platform or pay anything. It's all free and open source. But if you want to have like streaming data, there are some stuff that's gonna be easier if you are some paid services like MLflow or something like that. But there are some examples out there using Kafka and using MLflow with Apache Spark streaming sets. So that can work for you as well. I didn't have the time to put that in this workshop, or Sam didn't have the time because he created all of this. But that can be happening as well.
Okay, wonderful. Now we have a question coming in from Sergio Gonzalez. Question is, how would you create different flows for the pre-processing phase as well, in case one tries different approaches to process the data and wanted to compare them?
Cool. Can I show my screen for a second here? Can you
Sure.
put? Let me know when people can see it, please. Okay, great. So what you're seeing right now is the MLflow GitHub repo. If you go to examples, okay, and if you go to multi-step workflow, I think that will help you a lot. In this MLflow workflow example, you have the ETL steps, and this is actually for our recommender system. So for the person who asked for the recommender, this can work, and this is also working with Spark. If you don't know Spark, I don't recommend you see this, but there are some stuff happening underneath with Spark for for the ETL, and you have something for ALS, and then you have Keras. So you have a combination here of MLflow, Parquet, Spark, and Keras. So if you go to the multi steps and you go to the actual main folder in here, main file, sorry, this is the one that's going to be called by the ML project. Okay, so you have all of these definitions in here. Maybe this is not the best one. Let me just go here to the multi-step workflow again. And so in the ML project, this is it. You have the entry points is loading the raw data, doing the ETL, doing the ALS, doing the training the Keras, and then you define everything. So you can include everything in the in the project. You can include your CSV, your files for reading the data, for extracting the data, for creating features, everything that can be tracked with MLflow.
Okay, okay. Well, awesome, wonderful. Thank you so much. Now we have another question coming in from Marco. Marco asks, "Are you familiar with Koala's project for Spark? And do you prefer Scala UDFs over PySpark?"
So this is a very cool question. So can I share my screen again? Is it be shared? Can you let me know? Okay. So I am very close to koalas, but in a different way. If you search for Optimus by Spark um, online, this is a library that a friend and I created a while ago. And this is a library that happened before koalas. So koalas is a way to interact with pandas and Spark. I really like that library, but I think our library is a little bit better than koalas. It has more. It's also open source, by the way. You can get it here at hioptimus.com. You can click get it in here, and that will take you to the Optimus GitHub. So it is much more complete than koalas. Okay, it has a lot of different things, and by the way, I prefer PySpark than Scala because I don't use data sets. That it's only the only thing you cannot use in PySpark, so I don't care about that. So if you search here for our documentation, you see well we created a lot of great stuff for cleaning data, exporting the data, for all of that, and the API is not the same as Pandas. It's not the same as Spark. It's a combination of both. So, if you have the time, please check this library because the idea is you can combine the best of all of the worlds. You can use Optimus with Koalas and with PySpark. And if you want to know more about that, you can search online for the word Jungle Optimus. I know it's a weird sentence to write so Jungle Optimus Koalas. I'm sorry. If you search those three random words, you're gonna get an article from me. Okay, and that article from me is just telling you more about how to use koalas and pandas and Optimus and Spark. So in this article, I like it's like a competition. So you have the code For a Spark, with PySpark, you have the code in Optimus, and you have the code in Koalas, and the code in Pandas for each one of the steps of a data science project. So you can compare directly which one is better for you and which one you prefer. You have to use all of this. So it's not like you one prefers one over the other. It's all of them. You have to use all of them. So again, this article is just telling you how to do stuff with Spark, Optimus, Pandas, and Koalas all at the same time. And the pitfalls of Koalas, the pitfalls of Optimus, the pitfalls of Pandas, everything is in here. So hopefully you like it.
Okay, well, awesome. Thank you so much. Marco, I am 100% sure that your question has been answered to the fullest extent. Now, moving on to the next question. Srini asks, can we integrate MLflow with Databricks to schedule jobs in place of Airflow?
So I'm not entirely sure. I mean, I'm not like an active user of Databricks at the moment. I know that they have been working and stuff like that, and I tell you, like with Delta Lake and stuff like that, they're adding new functionality, and I know in the future that that's going to happen. Not only on Databricks, but they're going to add that functionality of DAGs directly into MLflow. That's happening right now. It's not into production, so it's not in production. You're not seeing it right now, but it's happening. Okay, so I think that maybe with a combination of Databricks and Delta Lake and MLflow, you can schedule jobs in Databricks. I think you have a scheduler in Databricks. I think so because I use that not with MLflow directly, but with Spark code. So you have a scheduler in Databricks, so maybe you don't need Airflow if you're using that, but you need to check directly with the provider.
Okay, well, awesome. I think that pretty much closes and that pretty much sums up this Q&A. And let me tell you, it has been an awesome and interesting Q&A session. Thank you once again, Fabio and Sam, for joining us. I can tell you without a doubt that the audience was enthralled, was thrilled. Well, Sam can vouch for that. He was constantly answering questions. And well, thank you so much. It was a pleasure hosting you, and I hope to see you all soon.